Topic 6-4, Trapezoids. This is referenced in our Holt textbook, Chapter 6, Section 6, page 427 through 435. Alright, let's look at some definitions first. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The base is the parallel sides, and the legs are the non-parallel sides. Base angles are at the bases. Let's just label this in the picture. Notice that your legs are the non-parallel sides, and notice that the base 1 and base 2 show the parallel lines. The set of base angles, in this particular one, it's denoted with one line here and two little curved lines here. That denotes that they are not congruent. Example. We'll learn later they can be, but this example doesn't show that. So you have a base 1 and a base 2. The important thing to remember here is that they will always be parallel. Your bases would be parallel. Isosceles trapezoid is where the two legs are congruent. This example is not an isosceles trapezoid, but that one would show, you could show one that has the exact same legs here and here, and that would be congruent. The diagonals of an isosceles trapezoid have a special relationship. So if we graphed this, and I'll make it a little bit darker, well, I'll actually use a highlighter. If we graph this MATH by plotting the points given, you would form, well, we're actually going to see if this name's a trapezoid. They're calling it an isosceles trapezoid. Okay, name the diagonals of the trapezoid. Well, the diagonals would be across from M to T and A to H. M, T, and A, H. Alright, we would want to find the lengths of both of these diagonals, because the theorem is that if they are, the diagonals of the trapezoid are congruent, then therefore it is an isosceles, and you would be able to mark these two legs as congruent. So using the distance formula, we will discover that the square root of 117 would be the diagonal MT, and the square root of 117 is diagonal AH. Therefore, this trapezoid would be considered isosceles. What can you say about the length of each diagonal? Well, the diagonals are equal to each other, and therefore it is an isosceles trapezoid, because in an isosceles trapezoid the diagonals are congruent. Example 1, we're going to see if this isosceles trapezoid determine if these statements could make it true or false. If AC is equal to BC, well, if they've already told us it's an isosceles trapezoid, that's a biconditional statement. You've already said that it's isosceles, so these two are congruent to each other, therefore the diagonals are also congruent. Is AD and BC congruent? Well, yes, that's true, because the legs of an isosceles triangle, by definition, are congruent. CA and BD bisect each other. Well, let's look at that. CA and BD bisect each other. Well, look at these lines. This line is definitely longer DE than EB, so that is not congruent to that. You would show that in different with different markings. So that statement's actually false. Example 2. Trapezoid DONE is an isosceles trapezoid. So we can actually mark the measurements. This and this are congruent if it's been denoted as an isosceles. And also this angle, full angle E. Actually, you can't name it angle E because it has, this is good to denote this, because it has a ray going through it. You have to name it DEN if you want to show this whole angle. And you would have to name this ONE to denote this whole angle. So if they wanted to see the EDO, they're telling us that this angle here is the one given as 110. And the measure of DEN, this one here is given to us as 15x minus 5 degrees. We know that consecutive angles equal 180, so this plus the 110, notice how they did that separately. If you need to see that that was in its own angle measurement for the measure of DEN, you can. But you have to remember that those are consecutive angles, so they equal 180. Solving this, you first combine the 110 and the minus 5 to get 105. Then you're going to subtract the 105 on both sides to get 75, and then divide by 15, so your x value is going to be 5. If they wanted the measure of DEN, then you would have to plug in the 5 for x, multiply by 15, and subtract 5. So be careful when they're asking just for the variable value or if they're asking for the angle degree. Okay, the last example. TRAP is an isosceles trapezoid. So if we want to mark, we know that this and this are congruent, and this base angle with this base angle, the whole thing are congruent. Those are the things you know about isosceles trapezoids. PR is 3x minus 7. So we're saying that this entire distance from here to here, and highlight that, is 3x minus 7. And TA, this entire distance from here to here, is 20. Well, we know that the diagonals are congruent, so set those two values equal to each other and solve, and you would get 9. Pause it if you need to take a minute and look more at that. Okay, the median. Here's another property of a trapezoid. A segment that joins the midpoints of the legs of a trapezoid. It is parallel to the base. Okay, so it is the midpoint of TP. That means that you can mark here and here being congruent to each other. If this denotes the midpoint of RA, put that with 2 marks because it's not congruent to the opposite leg, but it is a midpoint between the whole distance from here to here. The base is denoted by the parallel lines, and the median is the line that's created by joining the two midpoints together. A lot of times I like to show this with a piece of patty paper, in that if you measure, watch closely, you can do this too if you want to grab a piece of patty paper. If I measure TR, right here, this is TR, and then I slide it down to add it to the distance PA, and take from this point to this point. Let's see if you can see that. What I did was I took the top and the bottom, and then I'm going to show you that the median is the two bases added together divided by 2. So dividing something by 2 is taking half of it. So fold your piece of patty paper if you want to do this exercise with me, and slide it up along the median, where I've marked as the yellow line. And notice you're going to have the answer of the distance from, they didn't mark it, but this point to this point, denoted by the yellow line. So that actually proves that the bases added together divided by 2 is the median. So in an example, if they give you AB is 25 and DC is 13, you add these two together and divide by 2, you're going to get 19. if they give you that AE is 11 and FB is 8, then AD, which is the entire thing, to 11. If this is 11, then this has to be 11. That's where they got AD to be 22. Okay, to get to the whole distance for BC, 8, that's 8, and that's 8. 8 and 8 is 16. So that's where they got those. The last one, let me slide this up a little bit on this page. Actually, it's not the last one. We're still an example using this. If AB is 29 and EF, okay, so I've already drawn this in red, so you would have to either draw it again or just realize what you're looking for. In this case, they've given you the median, so you've already been given the answer using this formula up here, and that equal to bottom base and the top base we don't know divided by 2. So this is an example where you want to multiply by 2 on both sides. Why? To get rid of the denominator. That's where they got 48. So 48 would be equal to 29 plus x, therefore x is 19 once you subtract 29 from both sides. All right, if AB is this value and the median is this value, and they even give you the top value, you've got everything you need, the 2 top values plus the median. So if you're going to cut this in half, you've got all of the added top base and bottom base, divide it by 2, and you're going to get the 5y minus 3. Well, if your median is 5y minus 3, let's see what they do here. That is the median. We're trying to solve 4y, and they had already given us the EF. Oh, they already gave that, the 5y minus 3. So if you double this, it would give you the same thing. So if you're adding the 2 tops and bottom, this plus this is 8y, this and this is 4, and 2 of these, they didn't show that, but that would be taking 2 of those is equal to the same thing. So 2 of those is 10y minus 6. Solving for that, your y is 5. Take a minute, pause it if you need to go over that one again. I would say that one's going to be seen again. You'll see something like that on the worksheets. All right, example 5. Find the value of x for this trapezoid. Adding the bases. Now notice how the orientation of this trapezoid is your bases are over here. That is the bases, even though it's not standing like a normal trapezoid where your height measurement would go this direction. I'll try to explain that by your height is your height whether you're laying down or standing up. So your bases are actually denoted where the parallel lines are, not the non-parallel lines. Add 2 together, divide by 2. Your answer would be 29. If you're finding the value of this trapezoid, you know you're adding these 2 together, and divide by 2 is going to give you the middle that they've already given to you. So if you divide this 12 plus 30 divided by 2, you're going to get 42 divided by 2, which is 21. Keep carrying down the value of your median, solving for x, and you'll get 9. Just in summary, make sure you copy these. Exactly one pair of opposite sides are parallel, and a median definition is the 2 bases added together divided by 2. A few more things to remember is that the legs are congruent, the base angles are congruent, and the diagonals are congruent. And that concludes topic 6.4.